Hello everyone, welcome to Fahad's tutorial, and this is Fahad Hussain. In this video, I shall be explaining two different type of mathematics which is related with the chapter motion. In physics, you know, this is a very important and vital chapter to understand how to do the mathematics. Especially those students are studying in English version, you know that at least one or two questions you must have on your question paper from these chapters. So this type of questions is already in your book, but you need to do a practice a lot on these chapters mathematics. So I shall upload a series of class on this chapters mathematical problem solutions, and this is the first one. So as your better understanding from my previous class, I already explained that there are some equation of motion, four equation of motion, and we need to know that when we will use which principles based on the given data. And most importantly, this is very important to visualize the scenario, what is given on the question paper of physics. Suppose a huge, a big like this one is given on your physics questions, and you saw that you have to understand what's given and you have to understand what is required. So to understand this, we need to know that these equations of motions need to use based on the given data on your question paper. Suppose we know that there is a first equation like V is equal to U plus AT. Secondly, we know that S is equal to V plus U 2 into T. We have the third, S equals to UT plus half of AT square, and fourth, V square is equal to U square plus 2AS. So you know well, this four equation of motion, we need to use it based on the given data, and we need to understand what was the question and what is the data, what is the magnitude was asked in the question. So from today the series of lecture will be uploaded, and then we will explain it, we will do a lot of practice on these type of questions. Suppose this is the first one, and in the first question something is written like a car starting. So when it's written like a car starting from rest, if this things is written on your question paper, that means that you, and I just want to upload this one, that you, the initial velocity is zero meter per second. Okay, because it says that started from rest, moves with uniform acceleration. So there is a change of velocity per unit time and travels first kilometer. So here is given the distance, the first kilometer in 4 minutes. So here is a condition, first one, that a car is moving from rest and then it travels 4 minutes and it passes through the 1 kilometer. And then if the car moves with a uniform velocity, so there is a word uniform velocity, and from this word we need to know when a body is moving with uniform velocity, there is no acceleration. After this, how long will it take to travel the second kilometer? So the question is the time. So there is something we have to visualize what's going on here. So if we draw something like that if I think like this is a car and it's moving here, so from here it started and then it travels the first kilometer. So if I think that this one is S, it one is first kilometer, and we know that following the MKS system of unit, we need to know that here S in system international is 1 kilometer, so we need to know this should be 1000 meter. So it travels 1000 meters in 4 minutes. So we must say this T1 is 4 minutes And if it is 4 minutes, then we need to count that minute into second. So this 4 minutes would be 4 into 60 seconds, that would be 240 seconds. So following the questions, I am drawing a picture which will give me an idea what's going on here and what's the data is available in my hand and how to use it and which principle I should use. So here is S and we know there is 0, T1 is given, and after 1 kilometer travels it will gain a velocity. And then it was said that this is the second kilometer is again 1 kilometer, which is again 1000 meter, and this velocity will remain unchanged because it says it's moving with uniform velocity. So if it is uniform velocity, we must think this v will never change, and if it moves with uniform velocity, there should not be any acceleration. Here the value of a, the magnitude of a is 0. So when it travels with uniform velocity, the principle is S is equal to Vt. This should be remembered well. This is S equal to Vt. So I draw a picture, a very simple picture to understand what's given on the questions. And the question is how long it will take. So here we need to find out the velocity of t. How do we find the velocity of t from the given data? As because it's a 2 kilometer road, so first 1 kilometer is traveled with an uniform velocity, uniform acceleration. So we have for 1 kilometer, for first 1 kilometer road, what we have u. We have t1, which is actually 240 seconds. We have s1, which is 1000 meter, but we don't have v. But we need to count v because there is no acceleration is given, there is no magnitude of a is given, so we don't use anything which is here a is there, so we can use the second law as there is no magnitude of acceleration. So here we can say that v plus u by 2 into t for the first kilometer. So from here we can have this s1 and this t1. We know u is 0. We need to find out the velocity. Why? Because if we know the velocity, we have the displacement, and through this process, through utilizing this principle, we can find out the velocity of t. Because it was asked that how long it will take to travel the second kilometer. So from here we can find that S1 is actually, we can say that V plus U times T1 is equal to 2S1. So we know that U is 0, here is 0, so we have V is equal to S1 by T1. So if we just use the data is given to S1 is 1000 and T1 is 240 seconds, so we will have the value. So if I divide 2000 by 240, 2000 by 240, it will be 8.33 seconds. So it will be like 8.33 second. So, sorry, 8.33 meter per second. Meter per second, because this is the velocity and the unit of velocity is meter per second. So after 4 minutes travels, and when it passes through the 1000 meter, it will reach the velocity up to 8.33 meter per second. And following the question, if the car moves with the uniform velocity after this, that means after 1 kilometer the velocity won't change. And then if the velocity will remain unchanged, then the question is what is the time required to pass the 1 kilometer road. So from that purpose we know in case of uniform velocity, what we know? We know that S is equal to Vt, because velocity will remain unchanged. So if we use it, we know this, we will talk about the second half of the displacement. So it's 2 and this is 2, because this V will remain same. And the question is, how long will it take? So if we say that this is T2, then we can say that if it's T2, then we can divide it S2 over V. And then this S2 is actually 1000 meter. And then this V is just, we got 8.33. And the unit would be second. So this would be second. So if we divide 1000 by 8.33, our answer would be 8.33. Answer would be actually 120.05 second. So you can say 120.5 second. So this is actually the mathematics. And I hope some of you can have a very simple calculations over it, because some of you can know that this is very well-known questions, but those are actually studying in the English versions, and you know this type of question is available on a question paper, and if you can understand what is in the data and how to use the data to find the required data, then we can solve the questions easily. So this is the answer of the first question. So hopefully you know that how we think and drawing a picture. So if you understand this one, I'll erase it and I'll move into the second one. So let erase. Okay. And if you say the second part, what's given, the second question, what's given, like, this is a very interesting thing. This is actually a very interesting thing, and this question is very common. The given question is 2 cars. There is 2 cars. Starts the competition. There is a competition, and we know from our basic sense that a competition starts from a same point. So there is 2 velocity. Like there are 2 cars as given. So there is one velocity and another velocity respectively. It means this is the velocity of the first car and this one is the second car. So it's moving. And their acceleration is also given, which is also respectively this one and this one. So the question is, if 2 cars starts the competitions with 4 meters per second and 7 meters per second with 2 different velocity, they started, but their accelerations are different. And we see the very interesting thing, this one is comparatively smaller than this one, but the acceleration of the first car is comparatively higher than the second car. So though the second car starts with the comparatively higher velocity, but it gets a lower accelerations from the first one. And then the question is, if the clause is, if 2 cars reach the destination at the same time, then how long did they take in the competitions? So they take part the competitions. So the question is all about time. So they ask about how long. So it means we need to draw a picture. We need to see what's happening here. So if we draw just a pathway, there is a car and there is another car. It's moving. So both car has the same starting point, and fortunately they will have a very similar ending point too. So this is the first car. So we have initial velocity of 1, so we can write it as u1, and also we can have the initial velocity of the second car, which is u2. So 2 cars is moving from the same directions from a starting point, and there is a competition. So what we can say, that this car is moving with a velocity, and also this car has a different acceleration too. So if this car moving in this direction and this car is also moving in similar directions, and we can say that according to the questions, the required time is same for them. And of course, the distance or the displacement is also same. So the question is, what is the time required? Because there is a clue that said the time requirement was same. Because they reached the destination at the same time it was said. So how come we can solve the problem? So if we say that U1 is given 4 meter per second, the U2 is given 7 meter per second, A1, the acceleration of the first car is given 0.5 meter per second square, and the second is 0.4 meter per second square. If this is the condition, we know that for the first car, S would be, we need to know how to find out T, but there is no final velocity is given. So you won't use any principle which is related with final velocity. So what we can say that S is equal to ut plus half of a t square. So as it is the first one, we can say this was E1 and this is A1. But the t is same. That is now T1 and T2, because it says that the car ends or reaches the destination at the same time. So we can say for the second one, it should be u to t plus half a to t square. Okay? So if these two equations are same, as it's same because here the S is same, so we can write what? We can write a same part, like I just erased this part to make it quite larger one. So we can write that this one is equal to this one. So we can write E1t plus half A1 t square is equal to u to t plus half a to t square. Okay, we can write because we know the displacement are same. I need to erase it so that we can see things clearly. So if we can say that this one is equal, and from these we need to find out t, and that is the beauty of the calculation. Suppose there is an equation is given, and from that we have the data of 4 quantities, but we don't know the value of t which was asked to find it out here. So how we can do it? Let's have the same type of quantities in same side. So we can say that if we just put it here, this one here and this one there, then we can have a good shape of equations like u1t minus u2t is equal to, so if we like, half a2 t square minus this one on the other side, half a1 t square. Now we can take a common. So what's common in these two quantities? T. So it would be u1 minus u2, and then we can take a common half t square, then it would be a2 minus a1. So it's getting, general, and it's getting smaller. So we can erase t from both sides. So if we can divide by t on the both sides, we can have this t here only 1. And there is a 2 which will be multiplied by here. So from that side we can write this t is equal to, this one would be here, 2 u1 minus u2 over a2 minus a1. So now if we just put the data here, what will be the equations? The equations would be like this. So the calculation is 2. As you know that u1 is 4, so we can say 4 minus 7, and a2 is 0.4, so we can say 0.4 minus 0.5. So we can have the value from here to here. So we can have the value like this. So we say this is 2 and this would be minus 3, so it would be 2 times minus 3, and this would be minus 0.1. So we can have minus 6 over 0.01. So we can say that this minus will be removed. So if we divide 6 by 0.0, we can have 60 seconds. So we can have the answer. This 60 seconds is the required time. So how long did they take? They took 60 seconds. So this is the answer of the question. So I hope you understand how to solve this type of questions. So if there is something bigger written, a huge type of data is given on the question paper and you need to ask like something to find out what's inside, then you need to know that how to visualize the thing, how to visualize the scenario written on the questions, and then how to find the data, what was asked in the question. So I just simply simplified the equations, and there are some students also, those who have some idea to do it in a different way. Do it on your own, but I did it in this way to find it out, and I personally do that. What was asked in the question in physics, I just kept it in the left side, in my left hand side, and then the rest of the things will be on the right hand side, and then I put it down, and then I put all the data on the equations, and then I find it the value. So different way and different system you can follow, but as we are talking about the questions in the exam, so we all have a limited time in the exams hall, and to properly utilize our excellence and practice on that time. So we need to be very strategic, we need to be very fluent and errorless. So there is some explanation, and I'm explaining on the next video. There are some other type of questions which is very common in this chapter, motion. So see you on the next class. Take care and stay blessed.